Water is a source of life. It is one of the world's most important substances and it serves a lot of purpose. I'm thirsty. I need to drink water. I also needed to take a bath and clean my house. People need water to survive and they depend on it for cooking, bathing, washing, drinking, for safety purposes and other domestic needs. For potable water to be delivered in every establishment, a water supply network is needed. So, what is a water distribution system? How do this system works? A water distribution system is a system that collects, treats, stores, and transports potable water from a source to adequately supply water to consumers in residential, commercial, and industrial areas, irrigation, and for plumbing and firefighting equipment. Its functions is to provide appropriate quantity and quality of water for the community. It comprises networks of pumps, pipelines, storage, tanks, and other equipments. But due to calamities and corrosion, and the demand for faster distribution of quality water, the cost of minimizing and designing the water distribution system needs to be considered. Oh no! What are we going to do with this? How can we minimize the cost and design for water distribution systems? I need water. We will optimize the cost and design for the water distribution system by using the concept of minimum spanning tree. In graph theory, minimum spanning tree is commonly used for optimization problems. What is a minimum spanning tree? And how can we apply it in minimizing the cost of designing the water distribution system? A minimum spanning tree is a kind of graph wherein it is connected and it has no cycles. It connects every vertex with the minimum weight possible. In our case, the pumping stations are referred to as the vertex, and the pipelines that connects those vertices are referred to as the edge. I don't understand. Well, let me give you an example. When water is carried from a surface water treatment facility to a water provider, it must be connected to pipes to begin with the distribution process. Water providers are required to have pumping stations in order to provide water to a large number of settlements. For example, we have 7 pumping stations that are connected to 7 settlements. These pumping stations are connected with 12 edges with associated length representing the possible routes of the pipelines. Now, in order to keep the cost of building a water distribution system as low as possible, we must connect all of these pumping stations with the shortest possible length of pipelines. In the concept of graph theory, we were able to connect n number of vertices with only n-1 edges. But how will we know which route to use for the pipelines?
Well, this is where we should use the minimum spanning tree algorithm. First, we must arrange the edges with smallest to biggest weight. Sorting out gives us the result in the table. Now, in order to connect these pumping stations, we must use the greedy algorithm. We will get the first 6 edges since we only need 6 in order to connect 7 pumping stations. That will not create a cycle in the graph. Since the edge that connects pumping station E to pumping station G has the smallest weight, we will start with it. The next edge, which has the smallest edge, are edges that connects pumping station A to pumping station B and pumping station D to pumping station E. Next, with the smallest weight, is the edge that connects pumping station D to pumping station G. We can notice that adding this edge will create a cycle in the graph created so far, so we cannot include this. Next are the edges that connects pumping station B to pumping station E with weight 6, and the edge that connects pumping station C to pumping station D. And they can be included because it doesn't form any cycle in the graph. To complete our tree, we will finally add the edge that will connect pumping station A to pumping station F. We already connect the 7 pumping stations using only 6 edges with no loops and no cycles. We now conclude that this is the perfect network route for designing a water distribution system in the example given. Water can now be delivered to establishments fast and safely.
Yay! I can now drink water and do my chores.